Hi there. Today we're talking about scientific notation. So you may be thinking, what, am I watching the right video? Because I'm supposed to be doing math. Well, you're in the right video. This is math, but it is a type of math that is often used in science, and that happens a lot actually in math and science. Science uses a lot of math. So today we're going to be looking at a particular type of math used in science, and it's really just a way to write numbers. So this is what the number is going to look like. You're going to have a is going to be replaced with the number. A is just a variable. And then you're going to have this x, which means times, and then the number 10, and then an exponent will be replaced. We'll replace the n with a number as well. So you have a number times 10 with an exponent. And it kind of looks like a math problem itself, but it's really just one number that's being written differently. And we use this format, or when numbers are written in this format, they're said to be in scientific notation. All right, so right here we have several numbers that have been written in scientific notation, and so we're going to be looking at how you can, if we can figure out the pattern, okay, that's going to kind of describe to us what this whole scientific notation means. So if you take a look at the first one, 4.7 times 10 to the first power. So we know that anything to the first power is just 10. Here, or 10 to the first power is just 10. So 4.7 times 10, and I've written that that's equal to 47. So if you look down here, 10 times 4.7, I worked it out. 7 times 0 is 0. 7 times 1 is 7. Start with a 0, and then you do the same thing with a 4, and you end up with 470. But because there's a decimal here, then I need to put a decimal here, so I get 47. So this is 47, or 47.0. All right, if I continue looking at these numbers here, I know 10 to the second power means 10 times 10, right? Which is 100. So really, I'm multiplying 4.7 times 100. So I know that we said not to use the x anymore in math, and that's true. In math, we're not going to use the x, at least not for multiplication, okay? But in scientific notation, this is the way you're going to see it written. So even though it's not something we use a lot in math because we use a lot of letters in math, in science, a way to put something in scientific notation, it's understood that the x means multiply. So it's okay here, you wouldn't use letters necessarily right there. All right, so 10 to the third power means 10 times 10 times 10, which is 1,000. So we're going to multiply this one by 1,000. Okay, and then 10 to the fourth power means 10 times 10 times 10 times 10. All right, so hopefully you know fourth power means 4 zeros, so 4.7 times 10,000. All right, so we go ahead and figure out what these are. 4.7 times 100, 100 times 4.7 is 7 times 100, and then start with a 0. Oh, that's my dog, he scared me. And then 0 times 0, 4 times 1 is 4. So I'm going to add those up, 4700, and I have a decimal here, so decimal here, this becomes 470. If I do times 1,000, I'm going to do 7 times 1,000, gives me 7,000. Start with a 0, 0, 0, 0, and a 4, 0, 0, 0, 7, 4. And there's a decimal here, so there's a decimal here, so this would be 4,700. Are you noticing a pattern yet? Okay, what would you expect this next one to be? All right, looks like this number is getting a little bit bigger, right? 47, 470, 4,700. Let's do the last one just to be sure. So 10,000 times 4.7 would be 0, 0, 0, 0, 7. Start with a 0, 0, 0, 0, 0, 4, 0, 0, 0, 0, 7, 4. There's one decimal. Sure enough, is that what you were thinking it was? 47,000? All right, so what is the pattern? All right, well, you started with the number 4.7. When you multiplied it by 10, all right, what happened to that decimal? So 4.7, the decimal was here. It moved to here how many times? One time. All right, look at this one. 4.7 times 100. So the decimal started out here. When you multiplied by 100, you moved it 2 times. Where do you see a 2? Right there. 4.7 times 1,000. It started here and it moved 3 times. And look, there's a 3. Okay, 4.7 started here. It moved 4 times, and there's the 4. All right, this is not just a pattern. This is how scientific notation works, right? When you're multiplying by a positive exponent, all right, this number is getting bigger and bigger. And when you multiply by a power of 10, it's getting bigger by 1 decimal place, all right? What did we say about negative exponents? Okay, positive exponents repeat at multiplication. Negative exponents repeat at division. So what does that look like? 4.7, not times 10, but divide it by 110. Okay, another way to write divide it by 10 is to use the fraction, right? Times 1 over 10, or like we talked about negative exponents, you move it to the denominator. It means the same thing, 4.7 divided by 10. So if I take 10 and take 4.7 and divide it by 10, 10 will go into 4, it'll go into 47 4 times. When I subtract, I get 7, bring down a 0. 10 will go into 70 7 times. And looky there, I get 0.47. So what happened to the decimal this time? Okay, it started here, and this time it moved one place, but it moved the other direction, right? One time. 4.7 times 10 to the negative 2 is not divided by 10, it's divided by 100. So I'm going to do one more, and then I'm just going to look at the pattern. So I can't divide 4.7 into 4. Okay, bring out my decimal. I won't divide into 47. I need a 0 there before I add another 0. 100 will go into 470 4 times. And when I subtract, add one more 0, I'm going to get 7 times. All right, so this became 0.047. So look, I moved the decimal from here forward 2 places. All right, it moved up. And the number is actually getting smaller, right? Because I'm dividing by a bigger number, right? Each time, so the number gets a little smaller. But when you divide by 10, it's just moving it one decimal place. All right, so if I take this next one, 4.7, I guess I should stick with the x. And I'm going to move it this time, or I'm dividing this time by 1,000, right? Because 3 zeros. That's going to move my decimal place 3 times. So it starts here, it's going to move it 3 times. I'm dividing, so it's getting smaller. 1, 2, 3. So I'm going to add 2 zeros, right? Start it here, 1, 2, 3. Okay, and it becomes 0.0047. 4.7 dividing by 10,000, 4 zeros this time, right? So if my decimal starts right here and I move it 4 places, 4, 7, right? Move it 4 places, 1, 2, 3, 4. I'm going to add how many zeros? 3. So 0.0047. Okay, and you could test all of these, but they will work, trust me. Right? This is not just a pattern. This is what it means to divide by 10. It moves your decimal over one place. All right, so 5.34 is a number that's been written in scientific notation. Now, there are some things that have to be true. Okay, even in this form, there's a certain way to write it. The first factor, this number right here, 5.34, okay, is always a number between 1 and 10. 4.7 is a number between 1 and 1 and 10. You can't use 47. Okay, that would not be between 1 and 10. You can't use 0.47. Right? That's too small. Right? This number, 5.34, we can't use 53.4. Has to be between 1 and 10. Can't be in front of the 5. Okay, that would be too small. So the first factor, always between 1 and 10. The second factor, this one right here, is always a power of 10. Can't be something else. It's always 10 to the something power, right? When these two things are true, then this number is written correctly in scientific notation. Okay, why do we need to know this? Well, in science, you're going to see that sometimes the numbers you have to write are very large or very small. Okay, and that becomes more important when you're using a calculator a lot because you can't type. There's only a certain number of digits you can type on a calculator. There's only a certain number of digits the calculator can show you. Okay, so what happens is when the numbers get too big or too small, then it switches over to scientific notation. We'll look at this some more in class. Okay, but this is why we have scientific notation. We have to write very, very big numbers when you're talking about how many miles it is from here to outer space. Okay, that's a huge number. Right, when you're talking about how infinitely small an atom is. Okay, that's a super, super tiny, tiny, tiny amount. Okay, all right, so you're going to be practicing today going from scientific notation to standard decimal notation. That's just putting it in a regular number. Okay, and then also going the opposite. I'm going to show you both ways to do that. So the first thing to do when you're trying to take it out of scientific notation is to move the decimal the same number of decimal places, okay, as we're in the exponent. So you're going to look at the exponent and move the decimal that many places. If the exponent is positive, If it's a positive number, the number is going to get bigger. So the decimal is going to move to the right because the number is large. Okay, you want a big number, so you don't want to make it smaller. You want to make it to be bigger. If the exponent is negative, you're dividing, right? What happens when you divide? The number gets smaller, okay? It moves to the left because the number is small. All right, take a look at these. This is telling me, the exponent tells me to move the decimal place 4 places. 5.34, I'm going to move it 4 places. Is my number getting bigger or smaller? Okay, it's positive, it's getting bigger. So I want this number to get bigger. So do I want to move it left or do I want to move it right? If I move it this way, right, the decimal comes over here, it's getting bigger. So 4 places, 1, 2, 3, 4. Okay, if I can't move it 4 places, I'm going to add zeros to fill in these extra spaces here. So this becomes 53,400. All right, I'm going to start with 3.27. It tells me to move it 3 places, but this is a negative exponent. So I'm dividing, really, it's getting smaller. If I move this way, the number gets bigger. I'm going to move it to the left 3 places. So I'm going to add 2 zeros this time in front. All right, 7 times 10 to the 5th power. I'm starting with this number here. I'm moving the decimal 5 places. If you don't see a decimal, okay, where do we see a decimal? Where's the period at the end of the sentence? Okay, decimal's at the end of the number. So you're just going to put it there and move it 5 places. It's getting bigger. So to the right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that is 700,000. Right? To the negative 4, starting with 6.1, it's getting smaller. 1, 2, 3, 4. So adding 3 zeros, 0.0061. And the last one, 3.714. To be positive 8, right? So this is a big number. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Okay, so I'm going to do 3714, and then 1, 2, 3, 4, 5. 2, 3, 4, 5. All right, so put in some commas so I can read this. All right, so 371,400,000. All right, so that's going from scientific notation to standard decimal notation, to just a regular number. Now we're going to look at going the other direction. So to go the other direction, to go from standard notation to scientific notation, there are 2 steps basically. You want to move the decimal to the left to make a number. If the number is big, all right, then you're going to move the number to the left to make the number between 1 and 10. So remember, scientific notation, that first factor has to be a number between 1 and 10. All right, so I'm starting with a big number. To make this, to move the decimal, remember, where's my decimal? It's at the end. I'm going to move it to the right, okay? And I have to keep going until I get a number between 1 and 0. All right, so if I move it here, 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 okay? Now my decimal is 72 point something. I'm getting closer, but it's still not between 1 and 10. So I have to move 1 more place, okay? Now I have 7.2. Is 7.2 a number between 1 and 10? Yes. Okay, if I move it 1 more place, that's too many, right? Because 0.72 is less than 1. Right, so I've moved it over to 7.2. That's the first factor. Okay, what comes after the 7.2? The times 10 part. Right, so I just need to know what this exponent here is. All right, so I have to count how many numbers did I move over. 1, 2, 3, 4, 5, 6. I moved it over 6 times that way. Okay, 6 times. Okay, last thing you're going to have to decide is it positive or negative? Okay, so look at the number you wrote. Is this a big number or a little number? It's a big number, so it should be a positive exponent, okay? To go back, right? You can check yourself by doing the opposite, right? If I go back 6 spaces, right, it's a big number. Do I get the same number? Yep. Okay, look at this one. Same idea. This time the decimal starts here. I'm going to move it until I have a number between 1 and 10. So 1, 2, 3, 4. If I move it here, 0.31, not enough. 3.1, just right. 31, too much, all right, bigger than 10. So 3.1 is where I want to go. I need the times 10 part. 3.1 times 10. All right, how many places did you move it? So 1, 2, 3, 4, 5. I moved it 5 places this way. Okay, this number was small, right? It's a decimal. So my number, or my exponent should be negative 0.5. Check, is this the same as this? Yes, it is. Right? Notice that 0 here didn't count when I was trying to count up how many times I moved it, because this was just a placeholder. All right, so let's practice some more. Decimal starts in the back. 1, 2, 3, 4, 5, 6, 7. Why did I stop here? Okay, because this would be 1.4 something. That's what I want. 1, 2, 3, 4, 5, 6, 7. I moved it 7 places. I'm going to need to know that. All right, so this becomes 1.414. I'm going to write any number that's not a 0 down. All right, I can drop the zeros. And then this is going to be the times 10. I moved it 7 places. Is it negative or positive? Big number, positive. All right, here I'm starting with the 0.114. Got to get a number between 1 and 0. If I move it here, is that a number between 1 and 10? Yeah, this is 1.14. Is that what I want? Or do I want to go one more? If I go one more, it's 11.4. Okay, that's bigger than 10. That's too much. So I always move it so that it's 1 point something. It needs to be a number point something, kind of. Just kind of think of that. 1 digit point something. So this is 1.14. Okay, and this time I didn't really move it, but 1 space, right? Okay, is this a big number or little number? Little number, it's negative. Okay, so maybe not the best example for scientific notation, because even though this is small, it's not super, super small, but we're practicing. All right, here's a big number. I'm going to move the decimal till I get to 4, or a digit point something, all right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I moved it 12 spaces. So this is, I stopped here because now I have 4. I could put 0.0, but I don't need to. I can just put 4 times 10. Big number, little number, big number. All right, positive. Move the decimal, 1, 2, 3 spaces. Why only 3? Because this is 8.76. It's got to be between 1 and 10. I moved 3 places, and I made, this is a small number, so this is -3. Okay, over here, 1, 2, 3, 4, 5, 6. Do I stop? Nope, that's 2,000. Keep going. 7, 8, 9. All right, stop here. Yeah, it's 2.306 between 1 and 10. Yes, it is. Okay, so notice I kept going until I got to only zeros. All right, so 2.306 times 10. How many places? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. Negative or positive? Big number, positive. All right, last one. 1, 2, 3, 4, 5, 6. Don't want to stop there. 0.9. Nope, not big enough. 7, 9. Yes, 9 is between 1 and 10. 1, 2, 3, 4, 5, 6, 7. I moved it 7 places. So this is 9 point nothing, right? So just 9. And then 10, big or small? It's small, -7. All right, last problem. It says refer to the table at the right, order the countries according to the amount of money visitors spent in the United States from greatest to least. All right, Canada is 1.03. These are all positive, so they're all going to be getting bigger. So I'm going to move 7 spaces. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. All right, so my final number is what? 2, 3. Is this number right here? 10 million. All right, India, 1.83. I'm moving 6 spaces. So 1, 2, 3, 4, 5, 6. 1, 2, 3. That would be 1, 8, 3, 1, 2, 3, 4. So this number, 1,830,000. Mexico, 7.15. 6 spaces. It's getting bigger. 1, 2, 3, 4, 5, 6. So then that would be 7,150,000. And then 1.06 times 10 to the 7th. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5. All right, so that is 106,000,000. So that becomes 10 million. All right, so put these in order, greatest to least. So the biggest number is not 1 million or 7 million. It's in the 10 millions, and it's 10,600,000. So that was the United Kingdom. Okay, so I use that one. And then the next 10 million would be Canada. Okay, and then after 10 million would be 7 million, Mexico. And last would be 1 million, which is India. Okay, so that's my answer. And that's definitely one way to do it, but I do want you to notice, like here, these numbers, right, they're all 1 point something, 7 point something. So what's making this number big or small is the exponent, right? So really what I have to do, if I know that this is going to move 7 spaces and this is going to move 6, then this number is going to be bigger than this number, right? So really I just need to compare these two, right? These are the biggest because they move the most decimal places. And then what number is bigger here? The 1.06, United Kingdom. So if I just compare these two, I know this one's bigger than this one because this number is bigger than this number. I know that this number is bigger than this number because of the exponents. All right, so then since these have the same exponent, I'm going to compare this part. So what's bigger, the 1.83 or the 7.15? The 7.15, which is why Mexico came before India. All right, scientific notation, really helpful, not just in math, but in science too. All right, see you soon.